Hi, we are from Group 2, Section 6. Today we will present on Lab 2, which is the Introduction to PLC Programming using ISPsoft. Our group consists of 3 members, which is me, Betty Hoyole, matric number DE10076, Hani Farhana binti Hasbullah, Divakar anak lelaki Ravindran. So this experiment aims to provide knowledge in PLC programming using software ISPsoft, and there are two objectives. The first one is to familiarize with the technique to program PLC using ISPsoft, and the second one is to build up simple program, run and do troubleshooting. So what is ISPsoft? ISPsoft is actually a latest program development tool used for PLC, and it is used with COM-MGR as the communication port manager. In this lab, we will observe what happened to the output of each problem when the program is run, and we will observe the output of the circuit according to the input given in the truth table.
Assalamualaikum warahmatullahi wabarakatuh. And hi, my name is Hani Farhana binti Hasbullah, and I will present for question 7.1.1. So this is the output of the question for x0, x1, and the output y0. So here got the truth table for input x0, which is 0011, and x1 1010, and for the output y0 we got 0100. So from here the observation that we got from the result is the output y0 will turn on only when the input x0 and x1 are low, which is it shows that the value for both input is 0. So which means here when we got the input for x0 is 0 and the input for x1 is 0, so we got the output is 1, which it will turn on.
A very good day I would like to wish to Dr. Najib and my fellow friends. Now, I, Divakar Ravindran, will continue on with the presentation by presenting question 7.1.2, 7.1.4 and the conclusion of our lab. So for question 7.1.2, we can see that there are two different networks and both of them are in a series configuration. And this network 1 shows that there involves two normally open contacts with the output. Meanwhile, network 2 has three different contacts, two of them which are normally open and one normally closed with the output y1. So from our analysis, we have driven a truth table to identify the characteristic of this ladder diagram. So as we can see here, the light turns on. For network 1, it turns on only when x1 and x2 are 1 because they are representing or imitating a AND configuration in this network. Similarly, for network 2, it is the same. However, x4 is normally closed, which means that when the input logic at contact x4 is 0, it means the current will pass through this contact. So you can see it from the truth table here, whereby when x1 and x2 are on, y0 will become 1. And for this network 2 to be on, x4 will remain at 0, hence will turn on y1 when x3 and x5 are 1 and x4 is 0 right here. So we can see that the other state where we can show an example where y0 is the only one on is when x1 and x2 are 1. And when we set x3, x4 to 1, this contact will become open. Hence, the current will not pass through to the x5 contact. So it will not turn on y1. And the other one is just turning off both of x1, x2 and leaving 1, 0, 1 at this network 2 right here, which will cause the y1 to light up. So from this, we can see that output y0 will only turn on when inputs x1, x2 are high or 1, since their series configuration is an AND logic representation. For output y1, it will become 1 when inputs x3 and x5 are 1 and input x4 is 0, since it is a normally closed contact.
Now I will explain for question 7.1.3. This is the output circuit for the first row of the truth table, whereby we set the input x1 to x7 to off condition, which is 0. For a normally open component, which is x1, x3, and x7, when it is off, the current will not flow through. And for a normally closed component, such as x2, x4, x5, and x6, when it is off, the current will flow through. However, output y0, y1 will be in off condition because the whole network has no current flowing in due to x1 is in normally open condition. And for y2, it is off because for x7, there are no current flowing through, although x6 has input current. For the rest of the input in the truth table, it is tested using the same circuit and we have obtained the output as shown in the truth table.
Now for question 7.1.4, the ladder diagram shows the use of 8 contacts. 3 of them are normally closed and 5 of them are normally open contacts with one output. So From simulating this ladder diagram, we are able to obtain the truth table. For example, one of the combinations that will make the Y0 output as 1 is when input contexts x1 and x3 are set as 1, while all the other contexts are set as 0. So another example of condition that will set the output Y0 as 1 is when inputs x3 and x6 are set as 1. So whereby this input is set as 1 and it will transfer the signal into this contact and then will pass through x9, which is a normally closed contact, and when it's 0 it allows the signal to flow through and will make the output Y0 to set as 1. So from simulating this ladder diagram and making the truth table, we are able to make an analysis or observation whereby output Y0 will turn on only when X3 is on. Any combination of inputs of X1, 2, 5, 6 or 7 will not affect the output Y0 if X3 is turned off. Other than that, when input X or the context X4 is set as 0 and x9 is set as 1, the output of y0 will also be 0 even with the correct combination to trigger the output y0 to 1.
Question 7.2. It asks what will happen if the user did not click online mode when executing the program. So from here, if the user did not click online mode when execute the program, it will be the programs will be in offline mode, which the user can still edit the ladder diagram. But in online mode, actually we can see the current state of each input and output, which it will be lit up. So that's mean if we did not click the online mode, the program that we want to execute will doesn't show the state, which is it means if we did not click the online mode, the program that we want to run doesn't show any output. The output doesn't turn on or turn off when we run it.
Moving on to question 7.3, this question requires us to make one of the output Y0 or Y1 to be in on condition, but it doesn't mention the condition of Y2. So, as you can see here, this is the modified circuit from question 7.1.3, and this is the output of the circuit shown for the first row of the truth table, whereby I made all of the input from x1 to x7 to be in off condition. When normally closed input are in off condition, current will flow through, and when the normally open input are in off condition, no current will flow through. That is why between Y0 and Y1, only Y0 is on, because X3 is normally closed and X6 is normally open. And the same goes to other input in this truth table. The only one that will make all of it off is when we turn on x1, x3, x5, and x7, and vice versa for x2, x4, x6.
Discussion. From this lab, we are introduced to PLC programming by using software which is ISP Soft and COMGR. We required to install both software because both of it are related to each other in order to run the program for this lab. So in this software, we are asked to run the program and test the output. From the given programs in the lab sheet, we need to build it in the software. In order for us to run the programs, we must compile it first to check if there is any error in the programs that we have done. Then we can run the program when all of it have been compiled without any error. When we run the simulation, the input and output will turn on, so we need to observe the output from the results.
Now for the conclusion from this lab, we were able to simulate the ladder diagram for PLC through the ISP software. The software allowed us to implement various ladder diagram designs that consist of normally open and normally closed contacts in different configurations such as parallel and series. Furthermore, the software allowed us to actively change the input states to identify the characteristic of the ladder diagram and which combination of input condition triggers the output of the ladder diagram. Hence, by conducting different ladder diagram designs in the ISP soft, we were able to learn on how the output is affected with different configuration in series and parallel while implementing various contexts that involve the use of normally open and normally closed contexts. The information from the software allowed us to build a truth table to understand in detail regarding the characteristic of each ladder diagram presented in the lab sheet. And that is all from us. Thank you.